As part of the table listing and figure programming, so we will take a look at one of the adverse event tables today. So the title of the report is says Treatment Emergent Adverse Events by Preferred Term. Now on the left side here we have a screenshot showing the final output that we are going to generate, and on the right side we do have some notes about the table that we are going to create. So we do have some notes here. Let's assume that these are the footnotes that are to be presented below the table body. So the footnote says n is equal to, small n is equal to number of subjects with at least one adverse event. So small n is being presented here, and they have defined the small n as number of subjects with at least one adverse event. And then we have the footnote explaining what does capital N mean. So capital N is equal to number of subjects in the safety analysis set. So if you see, we have capital N presented under each treatment column. So, and what does this represent? It represents the number of subjects in the safety analysis set in that particular treatment. And then we have this third footnote which is saying percentages are calculated based on the number of subjects in each treatment of the population specified. So if we take a look at the second title of the report, it says safety analysis set, and the percentages are calculated based on number of subjects in each treatment. So we are presenting percentages here under each treatment column, and these are calculated based on the number of subjects in each treatment in safety analysis set for this table. And then preferred terms are sorted alphabetically. So in this first column, we are actually presenting the preferred terms. So when they are mentioning that these have to be sorted, or these are sorted alphabetically. And then finally we have a programming note which says do not present percentages when the subject count is 0. So if you take a look at this placebo row count for vomiting, as no subject has experienced vomiting in this treatment, so we are only presenting the count, and as instructed we are not presenting the percentages for such cases. So whenever we are given a table to work on, so we need to go through the components. The first, we'll go through the titles first. So it says treatment emergent adverse events by preferred term. So if we are claiming familiar with clinical domain terminology, so this table is about adverse events. And again, if you are familiar with CD standards and ADAM standards, you will know that adverse events data can be found in an analysis dataset called adae. And in this, we are being asked to present only a subset of the adverse events, and that subset is called like treatment emergent adverse events. And again, if you are familiar with CD standards and ADAM standards, we know that a variable called trtemfl is used to identify if a particular event is an adverse treatment emergent or not. And then coming on to the second title, so it says safety analysis set. Again, if we are familiar with CD standards, we know that a variable called saffl will be used to identify the subjects who are part of the safety analysis set. In general, safety analysis set is defined as the subjects who took at least one study drug dose. Okay, and then we need to see what are the treatments that are to be presented in the report. Here in this case, we are being asked to present three different treatment columns correspondingly: placebo, marketed product, and the test drug. And then we need to see what are the actual values that are to be displayed as part of this first column. If we see, the header of the column says preferred term, and if you are familiar with CD standards, we will know that the variable values can be found in a variable named aedecod. If we examine this table body, so we do have two sections presented. If we take a look at the first section, which says overall, here we are trying to present the overall summary of adverse events experienced by subjects. And here in the second section, we are actually presenting the individual adverse events experienced by subjects. So there are two sections in this report. And the next thing that we need to look is what are the different statistics that are being presented. If we see here, we are presenting small n and percentage of the subjects. So small n corresponds to the number of subjects experiencing a particular adverse event, and percentage is the total number of subjects divided by the total number of subjects available in that particular treatment. Now let us take a look at the input datasets that have to be used for this table programming. So for the purpose of this exercises, I have only given a list of variables that are required for this table programming, but on any regular case, you will find many other variables along with this set of variables. So we have usubjid variable, which indicates the subject number, and we have saffl, which indicates whether a subject falls under safety analysis set or not, and then the actual treatment that the subject has taken can be found in TRT01AN and TRT01A. So if we take a look at here, there are subjects who are part of placebo treatment and test drug. And make a note that we do not have any subjects in this data yet for the second column that was present in the table, that was marketed product. So but we still need to present that in the table with a count of 0. And then now let's take a look at the adae dataset that we are going to use as input. So in this dataset, the required variables are usubjid, and then the safety analysis set flag, and then the treatment the subject was on when the particular adverse event occurred, and it is present in a variable named trtan, and the standard medical terminology for the adverse event experienced can be found in aedecod variable. And then we also need the variable which identifies whether a particular adverse event is treatment emergent or not. So if you see here, there is at least one event which is not treatment emergent, and the rest of the events are treatment emergent. Before we jump into the programming aspects on how to program this table, we will take a look at the final dataset that we are going to create. So this is how our final dataset is expected to be in order for the report to be generated. So we will come to this final dataset creation, and we'll see all the intermediate steps that have to be used to get to this stage. Now if we switch back to the slides, so we will actually split our entire programming into different sections to achieve the final result. So if you see on screen, so there are around 11 major steps to get to the end result. So we will take a look at each of these individual steps along with the associated code that we are going to use to generate the final output. The first thing we need to do is to read and process the input dataset to select only those rows which are required for our table programming purposes. So we have seen that we only need the subjects who are part of the safety analysis set, and from adae we need only the treatment emergent adverse events of safety subjects. So in these two steps we are making use of where statement. In this particular step we are making use of where statement to filter the safety subjects from adsl. And in this second data step here, so we are filtering the treatment emergent adverse events of safety subjects from adae. And then if you have noticed that the treatment variable in adae was trtan and it was trt01an in adsl variable. So in order to harmonize for the downstream coding processes, I am creating a variable called treatment in both the datasets and assigning the respective treatment values from adsl. So this enables us to have some smooth processing in the downstream coding activities. And the next major step is to get the treatment totals into a dataset. So what we are trying to achieve here is, I'll quickly show you how the output dataset should look like, or the output dataset which we are expecting to be generated from this particular section of code. So we are planning to create a dataset with one row for each treatment and the number of subjects in each that treatment in a variable called TRT total. So now let's switch back to the slides and then see. So in this particular piece of code, we are making use of SQL to count the number of subjects in each treatment. Okay. So as we have noticed that in the input dataset, we did not have a subject who was part of the marketed product, that was treatment 2. So the output dataset generated by this particular piece of code looks something like this. So procSQL actually creates a row for each of the treatment values which are actually present in the treatment. Because we did not have a subject associated with treatment 2, there was no row created. But our expected output dataset was to have one row for each of the possible treatments and have the count as 0 whenever there was no subject in that treatment. So for this purpose, we do create a dummy data set containing all the possible treatments, one row for each treatment. Here we are making use of do loop and output statement within the loop to create that dummy data set. We'll take a look at the dummy data set that is getting created. So if we see, the dummy dataset that is created has 3 rows, one row for each treatment expected in this study. And then now what we can do is like merge this dataset with the actual counts dataset so that one row gets created for each of the treatments. So if you see here, we are making use of merge statement within a data step to merge the dummy data set where we had all 3 treatment rows present and the actual treatment rows. And then when we do a full merge, we get a row for each of the treatments. So as we do not have a row for treatment 2 in the treatment TRT total pre-data set, we would have the TRT total as missing. So whenever TRT total is missing, so we are setting it to null. So the output dataset generated is TRT totals. This is what we were referring to. So the dataset generated from these 3 steps, getting the actual counts, creating the dummy dataset, and then merging the dummy dataset with the actual treatments gives us the expected output. And then And in this next section, so we are creating macro variables to store the number of subjects in each treatment. So we are making use of calls input x routine of data step to create macro variables. So if you notice, macro variable names are being dynamically generated based on the values present in the treatment variable. If you see, so we are making use of the treatment variable values to create the names of the macro variables. So the expected values in treatment variables are n1, 2 and 3. So we are concatenating a n to the treatment value. So the macro variables generated out of this piece of code would be n1, n2 and n3. So where do we plan to use these macro variables is, so if we take a look at the report, so we are to present the number of subjects in each treatment under the column header. We get the number 2, 0 and 3 from those macro variables that we created as part of this step. And now we are jumping into the sections wherein we are actually obtaining the counts for our table body. So we had 2 sections, the first one corresponding to overall and the second section corresponding to the individual individual adverse events experienced. So as part of this step, we are getting the counts for top row, that is the overall row. So if you notice here, we are making use of proc SQL to fetch the number of subjects with at least one event in each treatment. So here the group by class only has treatment because we are only fetching the number of subjects with at least one event irrespective of the event. So by default, the count function gives the number of records with a non-missing value in specified variable. So a subject may experience one or more than one event. So but for this overall row, we need to count only a subject only once. So for that purpose, we are making use of distinct keyword. So when we use the keyword distinct, what happens is a subject will be counted only once, irrespective of the number of rows are there for that subject in a particular treatment. And then we are getting the counts for the second section, that is the preferred term level counts. So for this section, we are obtaining the counts. So here, if you notice, in the group by statement, we are also including the aedecod along with treatment. So when we run this piece of code, we get the number of subjects in each treatment and a particular adverse event would be obtained. And now we have obtained the two section related counts into two different data sets. We are trying to combine those two counts into a single data set. So the first data set was subject level count for the first section, and the second data set was PT count. So we are combining these two data sets to create a data set named count01. So in the next section, we are trying to create zero counts if an event is not present in a treatment. So there can be some adverse events which are experienced by only the subjects who are present in a single treatment. For example, we have seen that vomiting was only experienced by subjects who were present in test drug. But we still need to present the count as zero in other treatments. So for this, we need to create a full template or the dummy kind of structure. So in this section of code, we are trying to achieve that. So what we are trying to achieve here is to fetch the unique values in aedecod and label, okay, and then use this data set to create one row for each treatment. So basically in this piece of code, what happens is one row in dummy01. So let me show you the dummy01 data set. So we have overall section and the individual aedecods reported are present here. So we are trying to create one row for each treatment for each of these levels. So using a do loop with an output statement. So for each observation read using the set statement, the data set the observation gets replicated thrice or gets replicated once with the value of treatment 1 and the second instance of 2 and the third instance of 3. So let's take a look at the dataset dummy02 to see how this looks like. So we have how many rows here? So we have 5 rows, and in the output dataset we are expecting 5 multiplied by 3. So if you see, the total number of observations rows here is 16 minus the header row, which means there are 15 rows. So we have replicated each row thrice. And then we have the full template of events reported and all the possible treatments. So we now merge this dummy dataset with the actual counts dataset to create the full template. So whenever there is a row present in dummy but not in the counts, the count variable would have a missing value. So we are setting it to 0 to indicate that no subjects experienced a particular event in that treatment. So we will take a look at the output dataset that is generated, which is count02. So if you see, wherever, because we have seen that there were no subjects in second treatment at all, so but we still need to present the 0 counts for in each of those events. So we have created that treatment 2. This row was coming from dummy, and then it would have been null, but we have made use of that conditional if statement to set the count to 0 whenever it was null. So we have created the full template required. And then we need to calculate the percentages. In order to calculate the percentages, we need to have the denominator values alongside the count numerator values. The numerator values are nothing but the number of subjects who experienced a particular event. The denominator is the number of subjects who are present in each treatment. Okay, total number of subjects present in each treatment. So earlier we have obtained the total number of subjects into a data set named TRT totals, Now we are making use of that TRT totals and merging it with count02, wherein we had the subject level counts for each adverse event, and then we are merging it based on the treatment. So we will take a look at how would the count03 dataset look like after we perform this merge. So if we see here, now we have the variable TRT total coming from TRT totals dataset, which has the total number of subjects in each treatment. We have seen that there were 2 subjects in first treatment. So we have 2 value and all the rows corresponding to treatment 1. And we also had 3 subjects in a treatment corresponding to 3. So we have 3 value against all the rows of treatment 3. So there were no subjects in adsl with a value of treatment 2, so we do have the 0 count for that treatment. So in the next step, we are going to calculate the percentage and concatenate it with the count. So if we see here, we are making use of the put function to concatenate and making use of the concatenation operator to concatenate the counts and also the percentage. We are calculating the percentage here. So the numerator is the count value and the denominator is the total number of subjects in each treatment. So we are making use of that as denominator. In order to obtain the percentage, we need to divide numerator by denominator and then multiply it with 100. And then we are converting it into character format using a format of 5.1. And then if we also notice that there was a note saying that we should not present percentages when the subject count is 0. So we are achieving that by making use of this conditional if statement. We are concatenating the percentages or calculating and concatenating the percentage only when the subject count is not 0. Whenever the subject count is 0, which gets processed as else, so we are only concatenating the or converting the count to character format using put function. Let us take a look at the count04 dataset that is created. So we do have now the counts and percentages concatenated into a single variable. If you take a look at the individual column, so we have obtained the first section counts and we have indicated that section counts in a variable name label with a value of overall. So far we have 2 different columns to indicate whether it is particular section 1 or section 2. Now what we need to do is, like, for reporting purposes, we need to have all the values in a single column, the overall label and also the individual treatment. So in this section we are making use of some conditional if statements to fetch the values from the aedecod and populate it into the label column. And we are also creating a numeric variable to indicate whether that rows correspond to section 1 or section 2. If we take a look at the count05, we will get an understanding of what we are trying to achieve. So let us go to count05 dataset. So wherever label was populated, so we have earlier in count04, we have called it as order 1. So, and whenever it is missing, we are calling it as level 2. So these all of these rows correspond to the second section of the report and these rows correspond to the first section of the report. And now we have a single column that can be presented in the report, which have all the text that has to be displayed in the report, unlike the earlier 2 columns. So label and aedecod. So we have combined label column and aedecod column and created one single label column. Now, so far we have this longitudinal structure wherein the treatments are present as rows. But for our actual table programming, we need to have the treatment columns or treatments to be presented as columns. For this, we need to make some transposing to achieve this result. We will take a look at how to achieve that. So here we are transposing to obtain the treatments as columns. So we needed the order column, decode column, and label column as rows. So we are specifying that list of variables in the by statement. So whatever variables we specify in the by statement, those remain as variables or rows. And then we are specifying that the values present in count percentage variable, the CP variable, have to be transposed. And we also are using a statement called ID and specifying that treatment values have to be used. As so what happens with ID statement is that whenever we are transposing, we do get new columns created. So we are asking proc transpose to use the values present in treatment variable to name the newly created columns. So, and we are also making use of the prefix is equal to option to specify that the variable names have to be prefixed with the text trt. So we will take a look at the dataset that gets generated out of this code to see how the data gets transposed. So if you see, we now have one row for each level required, and the treatments are now transposed as columns. So this TRT is coming from the option prefix is equal to option we have used on proc transpose, and then this value 1, 2 and 3 are coming from the actual values present in count 05 on these individual rows. Now we are close to the structure which we want to the report to be generated. So here we will just keep some required variables only, or order the variables in such a way that that can be used to generate. So we are making use of keep statement to keep only the required variables that are needed for report generation. And now comes the report generation portion. So we are making use of outputs ODS RTF statement to route the output to RTF destination, and we are also making use of a predefined style set which is CSG pool 01 for the style to be applied to the RTF to be generated, and we are making use of some title statements to get the titles assigned. And then we have our proc report procedure. So in this we have to make a note of the macro variables that we have created to assign the number of subjects in each treatment to the corresponding treatment. And another thing to note here is we are making use of compute statement within the proc report to have the blank line created in between section 1 and section 2. So we have created our order variable in such a way that these two sections are identified. For the first section we have a value of 1, and for all the rows corresponding to the second section we have a value of 2. So basically with this piece of code what we are saying is that we need a blank line to be written for each change in order variable. So this is how we generate the final data set that can be passed into the report, and the report can be generated using the proc report code given here. So I plan to make some new videos exclusively explaining the different proc report options that have to be used to generate the report. So I am not explaining the reporting section in detail in this video. So thank you for watching, and I'll place the sample code that can be used to create the data sets so that you can work on the programming aspects. Thanks for watching again.